Hi friends, good afternoon. Today we are going to discuss Stokes Theorem, right? Last class we seen what is divergence theorem. In divergence theorem what we have seen? We converted a surface integral into a volume integral, right? Here what we do, line integral converting into surface integral, right? There surface integral into volume integral, here line integral to surface integral, right? So look here. So first of all I write the mathematical statement. See here, according to this theorem, see suppose you have a line integral, right? Integral a dot dl, right? Then instead of calculating this, right, you can take surface integral of, this is a vector field, right? So line integral of a vector field, right? That is equal to, take the cross product of this, del cross A, right? Del cross A, and then this length element changes to surface integral, right? Surface length element changes to surface element, right? So this is the basic mathematical idea. Now what is the significance of this, right? See, where we use this theorem, see, you know that integral E dot dl is equal to, what is integral E dot dl? Electric field. This is the potential, right? Integral E dot dl. Okay, work done to move a distance, right? So instead of calculating this integral E dot dl, you can calculate a integral del cross E dot dA, right? Why we are using this means, we can reduce, we can calculate it very easily, right? This integral, line integral, suppose you have a some rectangle given, instead of integrating all the side and adding, you just know about the surface element of this particular rectangular element, and using that you can simply calculate this, right? So let us do one example, then you will get idea, right? So let us go to a problem, right? See one question here. Suppose A is equal to 2xz, some one vector field is given, right? That vector field is A is equal to 2xz plus 3y square y cap plus 4yz square z cap. Check the Stokes theorem for the square surface shown in the figure, right? So square surface, so here one square surface is given, right? So look here, for this square surface we want to prove the Stokes theorem. Here given square of side length 1, right? And it is located in YZ plane, right? This square surface is located in YZ plane. So let us go to a plane board, right? Alright, see, so this is our square surface. First of all, I am doing, see, look here, this is our function given, vector field given in the question. Alright, this is the vector field. So to find the line, according to Stokes law, what I have discussed, integral A dot dl is equal to, that means line integral of A dot dl. A is any vector field, right? Equal to surface integral of cross product of the vector field dot the areal element dA, right? This is the Stokes law expansion, right? Now, so first manually we can calculate A dot dl. See here, A dot dl, for finding A dot dl, first right length is this. So first part I am calculating the integral. This is varying from 0 to 1, right? So 0 to 1, what is this direction? Y cap. This direction is y cap. So I can take this function, right? This function, but here this y is equal to, right, here this function 2 xz plus 3y square, right? So here for y is z square is z cap, but this length is varying from 0 to 1. So 3y square, see look here, I am putting 3y square y cap. Why? Because here z is equal to 0, then this part is not existing, right? Because this particular length on the y axis, so z is equal to 0, then this part is not existing, only y part is existing, then 3y square y cap. Now what is a small elemental length on the y axis? Dy, right? So dy, that direction is y cap. Now you integrate this y dot to y cap dot to y cap 1, y square dy on integration y cube by 3, then 3 cancel, right? And y square y cube on 0 to 1 limit giving, the answer is 1, right? Alright. Now the second part, now I am focusing in second part. Second part is along z cap direction, right? That is on z cap direction, right? So I have to take this as the function, right? For z square z cap, but here y is equal to what? For this line y is equal to 1. So if I put y is equal to 1, this is 4z square, right? Z cap, along z cap. And what is the length element in dz z cap? Now 4 into z square z cap dot z cap 1. Then z square dz on integration z cube by 3. Now I am giving 0 to 1, then 4 by 3 come answer, right? This 4 z cube by 3, that means 1 by 3, right? Z value turns into 1, alright. Now about this, right? This is negative of this, right? Because it is parallel to y axis but opposite direction, right? So negative of this integral, right? So minus 1. Now what about this? This is z cap direction but y is equal to 0. That means z cap direction only, it is located on z axis. So function you should take this, but it is along the z axis, y coordinate is 0. When y coordinate you give here 0, this integral doesn't exist, it will vanish, right? Then 0. Now add these all, that is 1 plus 4 by 3 minus 1 plus 0. What is the answer? 4 by 3. Now look into this integral. So we have to calculate in 4 steps, right? If function is very complicated, this 4 integral evaluation is very difficult, alright? Now see how using Stokes theorem we can calculate it simply, right? See, look here, del cross A, first you find del cross A. What is del cross A, right? So let me, so we can write del cross A first, right? Del cross A, right, equal to I cap, j cap, k cap, or x cap, y cap, k cap, right? See what is the dou by dou x, dou by dou y, dou by dou z. What are the function given? 2xz, x coordinate is 0, here x cap component is 0, y cap component is 2xz plus 3y square, 3y square, and z component 4y z square, 4y z square, alright. Now do this first, right? Here I am putting x cap, here I am putting y cap, here I am putting z cap. Then x cap into, right, dou by dou y, 4z square, dou by dou z minus 2x, right, minus y cap into, right, dou by dou x of this is 0, dou by dou z, so y cap component is not there. Now again z cap into, right, dou by dou x, that means 2z, alright, 2z, right, dou by dou x 2z minus 0, alright. Now See, look here, this is the cross product I got. Now look here, let me use one, I am taking this again. Now what is the, now I am considering, when I am considering this area, right, this area is projected along x axis, right. What is this area element? It is along the yz plane. So dy dz x cap is the aerial element, right. The direction of this area is x cap. What is aerial element? That is dy dz, right. Now, so I want to calculate this del cross A dot ds. So surface integral, right, del cross A I got, that is x cap 4z square minus 2x minus plus 2z z cap, right, dot, what is this area element? Now aerial element I am writing dy dz, this is x cap, right, equal to, see here x cap dot x cap is 1, x cap dot z cap is 0, right, because angle between Cartesian coordinate dot product between different unit vector is 0, right. Now, so I can write this as integral 0 to 1, limit is 0 to 1, right, 4z square minus 2x, 4 is double integral 0 to 1, 0 to 1, 4z square, right, because aerial element dy and dz both the limit is 0 to 1, right, 4z square minus 2x, right, and dy dz, dy dz. Now see, this area is situated in yz plane, that means x is equal to 0, because area is enclosed in yz plane only, then x is equal to 0. So if I put x is equal to 0, so what finally I can write? So let me erase here. Okay, so x is equal to 0, if I give 0 to 1, again 0 to 1, right, 4z square dy, 4z square dy dz, right. So first I am integrating with respect to dy, that is y, 0 to 1 giving, again 1 only come, then remaining is 0 to 1, 4z square dz, then 4 I am taking out, z square on integration, z cube by 3, that is 0 to 1, again 4 by 3, right. So the same thing I got here, by separately I am calculating line integral, right, and adding the final result I got as 4 by 3. Here by RHS of Stokes theorem, by finding surface integral that enclosed by that line elements, when I am integrating that I am getting 4 by 3, right. So in different length element problem, we can that is multiple integration we can reduce, and by a single step we can find answer, all right. So this is all about Stokes theorem, and we will do more problems in Stokes theorem and divergence theorem at the end of the lesson. Okay, thank you.